Okay. Now, let me give you some questions. Say 200.50.29.39. So what you have to do is you have to find the class, you have to find the subnet mask, you have to find the network address, you have to find the broadcast address, and you have to find the assignable IP address range or valid IP range. So this is the first question, and the second question is 129.5.6.7. And the third one, suppose 126.55.66.77. So guys, regarding the first question, which class it is? Class C or A? C. Okay. Now, what is the say subnet mask? Default subnet mask. 255 dot 255.255.255.0. I hope you guys have written it exactly like this, right? Now, so let me ask the next question. We'll start from here. Okay, so what is the network address of this one? 200.50 dot, sorry, 200.50 dot 29.0. Yes, exactly. So that's the network address. Okay. Now, let me ask the next broadcast address here. 200.50.29.255 is the broadcast address, right? And the assignable IP address, who will tell? Yes.
200.50.29.12 200.50.29.254.
Yes, 200.50.29.254. So this is the assignable IP range, right? Okay. Now the second one will start from here. Yes. Which class it is?
Class B.
Class B. Yes, very good. And you can even tell the defaults of the mask.
255 dot
255 dot
255 dot
255 dot 0.0. Exactly. That's the defaults of the mask. And the network address.
129.5.0.0.
Yes, 129.5.0.0 is the network address. And the broadcast address there. Yes.
129.5.0.12.
That's assignable IP. Okay. So I'm asking the broadcast address.
129.5.255.
Yes, the broadcast address is 129.5.255.255. And the assignable IP address. So Smith, right? 5.0.1 to 129.5.255.254. So let me ask you one question, simple thing. Suppose this is 12 o'clock. 12 o'clock. So which is the just previous second, what will be the time? Or just previous instant, what will be the time? 11:59 minutes, 59 seconds. Exactly the same thing. Say just before this this broadcast address, you have the IP 129.5.255.254. That's the only thing. Got it? Okay. Now the next question, say, what is it? 126, sorry, this question. So just a moment. Yes, there. Yes, class A, excellent, very good. Now you can tell the defaults of mask. Yes, defaults of mask. 255.0.0.0. Exactly. And the network address. 126 dot 0.0.0. Right. Everything, all the host portion is 0. Okay. And say the broadcast address there. 126 dot 255 dot 255 dot 255, the broadcast address. Okay, sorry. If at all I have told you the assignable, it's not assignable, it's broadcast address only. Okay, broadcast address. Now assignable IP. Yes. 126 dot 0.0.1 to 126 dot 255 dot 255 dot 254. Very good. Got it, guys? Everyone? Okay. So now to study this, I'll give you 2 more days. Okay. So these are the basic things that you need to know before we go to a portion called subnetting. Okay. You might have heard of the term or might not have heard. So for subnetting, for studying subnetting, these are the basic things. Okay. So I'll give you 2 more days to study. Okay. So maybe not day after tomorrow, maybe on Monday we'll start. Okay. So today, let me start a theory portion. Okay. So we'll go on with a theory portion. And the topic name is OSI reference model. So you can write the heading OSI reference model. So online guys, don't worry. Maybe later I'll ask you questions. So I only asked offline guys the questions, right? Okay. So now, before teaching you this OSI reference model, okay, we'll start with a small story. Shall we? Yes. Okay. So now, suppose Again, only two names I know. Leave it. No, don't tell your name. Who is Raghavendra? So you guys are like changing the seats, right? Okay. Yesterday you sat here. Right. Okay, no problem. So no issues. Anyway, I'll come to like study your names later. Okay. Now, so suppose we got Vaman. Okay, so Vaman, I'll be taking you as the example every time. And Susmit as well. Okay. So suppose Vaman. So Vaman, so he has started a company. Suppose he's in 1970s and something. Okay, at that time. Suppose by that time, Vaman say he started an IT company or he started some firm. Okay, and that firm needs computers. That firm needs computers. Suppose Susmit, he owns a computer manufacturing company. Okay, don't worry. Next, I'll get you. Okay, so Susmit, suppose he owns a company, say it's called ABC Company. This company manufactures computers. Okay, so this company, say, let me tell you, this company will have their own research and development team. And they will be manufacturing the computers, and these computers will be working based on the R&D team's protocols, or they will come up with certain rules and regulations called protocols, and this company's computer will work based on those set of protocols. Clear? So they will work in a specific manner. Okay. Now, so Vaman has bought, say in the first year, he has bought 100 computers from this ABC company. They bought 100 computers from the ABC company. Okay. Now, so he was working smoothly. He's working fine, perfectly fine. In the next year, suppose you got another company came up, XYZ company, who is also a computer manufacturing company. Computer manufacturer. Okay, and this XYZ company, they have their own R&D department, and the R&D department will be developing their own set of protocols. Okay, so suppose XYZ works on different set of protocols. Clear? Now, so in the next or the second year, this Vaman, he bought computers from XYZ company. So later on, he started facing some issues, right? So when the computer from ABC company is connected to the XYZ company, or if something is sent from this ABC company to the XYZ company, then the problem starts. Because this ABC company will be working in one manner and this XYZ company will be working in another manner. Yeah, and that is why that is where the problem has started. So if suppose he is sending hello, how are you? Some message. Okay, but XYZ company is, or this computer is processing something else. Okay, so he's processing at something else and he's replying back some nonsense, whatever it is. Okay, so it is not a proper communication, right? So say whenever something is processed, it has to be processed in the same manner at the other end. Clear? For proper communication, it has to be. Okay, now, so then an organization called ISO. An organization called ISO, International Organization for Standardization. International Organization for Standardization. So this ISO has come up with a set of protocols, set of rules and regulations, and that is called OSI model. That is called OSI model. Okay, OSI means Open System Interconnect. Open System Interconnect. Okay, so ISO came up with something called Open System Interconnect or OSI model, and they told everyone, all the computer manufacturing companies, say suppose ABC company or XYZ company or whatever, whoever it is, they told, say all the companies to start moving or to start developing computers based on the OSI model. Okay, so that everyone, all the computers will be, or the protocols will be standardized and all the computers will be able to communicate with each other. Clear? So everyone, they moved or they started moving or they started developing the computers based on this OSI model. Okay, now, again, after or by 1990s, again, another twist came. Okay, let me tell you. By 1990s, US Department of Defense Department of Defense, they developed another model called or TCP/IP model. It's called TCP/IP model. Then all the computer manufacturers, they started say migrating from this OSI model to TCP/IP model. So now all the computers are working based on the TCP/IP model. Now what ISO did was, this is the first standardized model. This is the first standardized model. So they have made this OSI model as a reference model. Now the OSI is a reference model. Clear? So that is why we are studying this OSI model. That is a reference. Shall we now? Okay. Now, so suppose, so when you study this OSI, or when they came up with this OSI model, the working of computer, they have simplified the working of a computer into 7 parts. They have simplified the working of a computer into 7 parts, or specifically 7 layers. Very good. Clear? Okay. Now we shall be studying about all these 7 layers. Okay. So let me tell you about the layers here. These are the layers. Okay. So you got layers: application layer, presentation layer, session layer, transport, network, data link, and physical. Okay. These are the layers. OSI layers. Okay. Now let me tell you, application layer is called layer 7. Now presentation layer is layer 6, session layer is layer 5, transport layer is layer 4, network layer is layer 3, data link layer 2, and physical layer is layer 1. So if somebody asks you what is, or which is the physical, or sorry, which is the layer 1, what are you going to answer? Physical layer. It will definitely, and it is always physical layer, which is layer 1. It is never application layer, which is layer 1. It is always layer 7. Clear? Okay. So these are the layers. And let me tell you about OSI. Okay. OSI is the very fundamental of networking. Okay. All concepts, or each and every concept in networking, can be explained with the help of this OSI model. Clear? Okay. Yes. So now, if you want, you can write it down. These layers: application layer, presentation, session, transport, network, data link, and physical layer. No. Sajin. Deva. Got 2 more names. Ashwin. Okay, Raghavendra. Salma. Okay, got some more names. Okay. Yes. Shall we? Okay. So now, so these are the layers. Okay. Now, so these 3 layers, layer 7, layer 6, and layer 5, or application layer, presentation layer, and session layer. These 3 layers are called upper layers. These 3 layers are called upper layers. And obviously, the rest 4 layers are called lower layers. Okay. Yes. So now we'll just discuss the small things about the upper layers, and we'll be discussing more about the lower layers. Okay. Now, let me ask you, or let me tell you one thing. So while teaching you the router, so we had a small section about router and all, right? So while teaching you router, I might have told you the router is a device which works on layer 3. It means it works on network layer. Okay. Now switch works on data link layer, layer 2 or data link layer. Now hub works on physical layer or layer 1. Okay. Similarly, so in L3 or network layer, we have got an addressing scheme, which is called layer 3 address, or it is called IP address. So IP address, it works in network level. Okay, similarly, MAC address is layer 2 addressing scheme and it works in data link level. Clear? Okay. MAC address works in layer 2. Okay. Now, yes. So let me discuss this figure now. Suppose you got two machines, machine 1 and machine 2. Machine 1 and machine 2. This machine 1 wants to send something to machine 2. Okay. So if machine 1 wants to send, suppose a hi message, he wants to send a hi message. So this hi message now is passed through each and every layers. It is now passed to each and every layers, starting from the application. So this first machine is sending something to the second machine. So who is the sending machine? The sender is the first machine. Okay. And the receiver is the, or the destination is the second machine. This is the destination. Okay. So, or sender or the source machine. So at the source side or at the machine 1, at machine 1, this message is first passed to layer 7 or the application layer. Okay, it is first passed to the application layer, where application layer will process it, will process this message. Will process means it will add some values to this message. It will add some values to this message. And this value is called header. It's called header. So you can say application layer has added a header to the value, to the message. And it is then passed to the presentation layer. Okay, so this value is now passed to the presentation layer. The presentation layer, which is layer 6, will add another value or another header. The presentation layer header will be added by the presentation layer. And this entire structure is being passed to the session layer, which will add the session header. Okay, then it will, then this structure, the whole structure is then passed to the transport layer, which will add the transport header, and which is passed to a network layer, which will add a network header, and to the data link layer, where they'll add not only the data link layer header, but also a data link layer trailer. A trailer is also added. Clear? Then it is sent through the physical layer. It is sent through the physical layer. So this physical layer is the cables. These are the cables. Cables or the wireless media, those things. Okay. So these information is sent through the, these are sent through the cable or the cables. Now, at the destination side, the destination receives it through the cables. Then it will pass it through the, or it will pass it to the data link layer. And the data link layer, what he will do is that whatever he has added at the source side, he has added a header and a trailer. So this header and trailer are removed at the data link layer. Then pass to the network layer, which will remove the network layer header. Then pass to the transport layer, which will remove the transport layer header. Again, pass to the session layer, which will remove the session header. Pass to the presentation layer, which removes the presentation header, which is passed to application layer, which removes the application header. And finally, the message is received at machine 2. Clear? This is the process that happens in this OSI. Clear? Okay, and not yet finished. Let me tell you. So you can see, I told you at the source side, we will be adding some values called header. And this process of adding the header is called data encapsulation. It's called data encapsulation. Clear? Now, at the destination side, whatever header is added is removed. And that is called data decapsulation or data de-encapsulation. Okay. So at the source side, data encapsulation happens, and at the destination side, data decapsulation happens. Clear? Okay. So now, if you want, you can write it down. Or guys, if at all you are drawing the same figure, you can take a photo, or say, suppose I'll share the PPT. Okay, then maybe you can copy it later. Okay, shall we now? Okay, I suppose you have understood, right? Okay. Now, but again, this has not finished. Let me again tell you. Okay, so the next thing, so you can see at each layer you have got a structure here. So this is the structure at the application layer. This is the structure at the presentation layer. This is the structure at session layer. This is the structure at transport layer. So this structure is collectively called as PDU. It is collectively called PDU, or it's called protocol data unit. It's called protocol data unit. Okay. So upper layers, for application layer, presentation layer, and session layer. So for the upper layers, the PDU is called data. For upper layers, the PDU is collectively called data. For transport layer, this structure which involves the message, then the application header, then the presentation header, the session header, and the transport header. This structure is called segment. Okay. And at the network layer, this structure which includes the message, application, presentation, session, transport, and network headers. So this structure is called packet. And when it is at the data link layer, this structure is called the frame. Okay. And again, at the physical layer, through the physical layer, we'll send the data as ones and zeros, or through as the electrical signal, or whatever it is. Okay. So at that time, then the value is called bits, or bits. Clear? So again, let me tell you, the PDU at the upper layer is called data. The transport layer PDU is called segment. The network layer PDU is called packet. And the data link layer PDU is called frame. And the physical layer PDU is called bit. Clear? Okay. Now, again, the next one more thing. So here I told you, say the presentation header is, say at the source side, the presentation layer or any layer, they will add the headers. They'll add the headers. And these headers are removed at the same layer at the destination side. Say suppose the presentation layer is adding something, and at the destination side, the same presentation layer will be removing the presentation header. Right. So you can say there is a kind of same layer interaction. There's a kind of same layer interaction. Okay. Now, in the same machine or machine one, you can see, say the presentation layer, after adding the header, passes this structure to the session layer. Right. So there is an adjacent layer interaction. After adding the headers, they will pass it to the adjacent layer, and that is called adjacent layer interaction. Clear? Okay. So I suppose you have understood what is this PDU, what is this adjacent layer interaction, and what is the same layer interaction. Okay. Yes. Now, so this we have discussed PDU, data encapsulation and de-encapsulation, same layer and communication, adjacent layer communication, upper layers and lower layers. Okay. Now we shall be discussing each layer. Okay, but upper layers we'll discuss only small things. Lower layers we'll discuss it in detail. Okay. So now, so guys, again, if you need a break, let me know, because this is completely theory. Okay, this OSI is completely theory. Okay, now, so we'll first come to the upper layers. Just give me a moment. So first is the application layer. First is the application layer. So application layer, so you can say, so if you have computer, okay, and we are the users. So this application layer will act as the interface between the user and the computer, the user and the machine, or it acts as an intermediate between the user and the machine. Now, this application layer, you can say, it provides the applications with services, or you can say it provides services to applications. It provides services to applications. Let me tell you an example. Okay, suppose feeling sleepy. Okay, sure. Okay, so whenever, even I will find many students sitting like this. Okay, so again, in many classes I used to tell them the same thing. Whenever you sit, someone sits like this, I'll get reminded of my college days where I used to sit like this and will be opening my eyes and will be sleeping like this. Okay, so I suppose you're not sleeping, right? Okay, just joking, but don't sleep. Okay, yes. Now, so here, yeah, I was about to tell you about application layer. So now suppose you want to, just an example, a simple example. Suppose you are watching a movie, or you got an MP4 file, MP4 or an MP3 file, which is either a video file or a voice audio file. So if at all you are using an MP4 file or MP3 file, or you want to play it, then you will use some application. So this MP4 file needs to use this application. So this application layer provides these services to the application. Clear? The same thing again. Let me again tell you. Suppose you are using the web browser. You're using the web browser. So to browse the web, you will be using, or you will be giving www.google.com is what you will type. www.google.com. Or you will type something like this: http://www.google.com. Okay, there what we are doing is that we are trying to browse the internet. Or if at all you are, suppose you are accessing www.facebook.com. Okay, what happens is that you are really accessing from your computer. Suppose this computer is in India. You are really accessing a server of the Facebook server present in somewhere, maybe in US. We don't know the location. Somewhere, maybe in US, suppose. Okay, so you are really, say, suppose you have your friend. You are seeing your friend's photo. So this photo is uploaded in the server. So it is somewhere in the US or some other place. So what you're doing is that you are accessing the photo or those things which are present in some other server. Clear? So you are, say, using the HTTP service, which is called Hypertext Transfer Protocol. Hypertext Transfer Protocol. Clear, guys? Okay, so while using this web browser, HTTP service, or to use the HTTP service, the web browser can be used. So these definitions or these things are, say, mentioned in the application layer. Clear? Okay. Again, so again, you got different protocols in application layer. Okay, so one example is HTTP. One example is HTTP. Okay, and second protocol. So these are the protocols. So let me show to you. So at each layer, you have different protocols. Okay. So in application layer, we have HTTPS1 protocol. And you have another protocol called FTP, file transfer protocol. Then SMTP, this is simple mail transfer protocol. Simple mail transfer protocol. It is used to transfer the mails. Okay. Now DHCP, I might have told you about DHCP briefly. You will study it later. Okay. So this is dynamic host configuration protocol. Dynamic host configuration protocol. DNS, domain name service. Telnet, it is remote login. Suppose you want to access a device. You are in US or you are in India. You want to access a router. You want to access a router which is present in US. Okay. Or you want to configure a router present in US. What will you do? You will use this Telnet protocol. You'll study it later. Okay. So these are the application layer protocols. So many application layer protocols are there. For now, this is sufficient. Clear? Everyone? Raghavendra? Okay. So Raghavendra, I'll make it short as Raghu. But still, I have to remember your name as Raghavendra. Then only I'll be calling as Raghu, right? Okay. So now, these are the application layers. Okay. Now the presentation layer. Shall we? Okay. Yes or no?
Yes.
Okay. So now, and again, so if you like be active, you will not feel sleepy. Okay. There is one more like method that I used to find useful when I sit in the classes. Okay. If somebody asks something, you can be active. At least yes or no. Sometimes say when I was asked whether you got any doubts, I simply told yes to my teacher, while I thought whether you understood or not. That was the question that I thought, but I gave the answer as the reverse answer. So he asked me, what is your doubt? Then I was like, blank. I don't know what to answer. So don't be like that, be active. Okay. Now, presentation layer. Okay. Presentation layer, as the name itself says, it helps us for presentation, or it helps us to present the data. How to present the data. Okay. So how to present the data means, suppose the alphabets A, B, C, D, E, F, G, H, these values. Okay. So for some computers which are in IBM standard, computers, these alphabets are represented using a code called ASCII code. You might have heard, might not have heard. Okay. So ASCII means American Standard Code for Information Interchange. Okay. Just certain numbers. Okay. Maybe A will be represented using the number. I really don't remember the number and all. Suppose it's 30. Okay. Then B will be like represented using a number 31 or something. C as 32 or something. Some numbers will be used for representing these alphabets. Okay. Similarly, if suppose the computer is of mainframe standard, another representation is used. It is called EBCDIC. It's called EBCDIC. EBCDIC. Extended Binary Coded Decimal Interchange Code. Okay. So how to represent the data? That is what which is mentioned in the presentation layer. Clear?
Yes.
Okay. So now, this presentation layer helps for the data presentation, how to present the data. And the next function is encryption. It will encrypt the data. Encrypt means, say, suppose some message, suppose Ashwin wants to send a message to, what was his name? Anish. Okay. So Ashwin wants to send something to Anish. Okay. So we have Sajin in between and Susmit in between. Sajin and Susmit. So Sajin and these guys, Ashwin and Anish, they are sending something secretly. Okay. They are planning for some surprises to Sajin and Susmit, suppose. Okay. So then they will, whatever they'll send, say, suppose they are planning for some birthday things or something. So Sajin and Susmit are celebrating their birthday at the same day or something, and they want to surprise them. Okay, so they'll be sending like that. Say Ashwin will be sending something to Anish. Hey Anish, today is their birthday, and we want to do or say we want to celebrate it like that. He's sending just a message. So Sajin and Susmit should not read it. Right, Sajin and Susmit should not read it. So what they will do is that they will use some quotes. They'll use some quotes. Okay, so the quote, suppose say today is his birthday, or some code will be there. Okay, for that they are writing 241#83 something like that. Some code will be written, or you can say it will be encrypted. It will be encrypted so that the values, the actual values cannot be read. Clear? Okay, so this encryption is done in the presentation layer. Okay, now again another function is compression and coding formats. Compression and coding formats. So these are the functions of presentation layer. Okay, so data presentation, encryption, compression, and the coding format. Clear? Okay, now so this is the presentation. These are just theory. Again, just understand, that's it. Nobody is going to ask you about say some interviews they may ask, but only the basic things. They are not going to ask you the in-depth things at all. Okay, but again, if you go to the security level, there you will study more about the presentation layer, or there you will study more about the encryption, those kinds of things. Okay, for now it's not really necessary. Okay, now the next is session layer. Session layer. So what is the session? What is a session? Any idea? So guys, if I ask you, or say if somebody asks you what is your CCNA or which is the CCNA time, CCNA class session, or if somebody asks you what is the time, then what will you say? It's from 5:30 to 7:30. So that's the session time, right? Session here means time interval. Okay, so this is the time interval for your class. Same thing. So what happens is that if you want to send something from the source to the destination, they'll have to create a time interval. Okay, so this time interval or this session creation, session management, and session termination, everything is done by the session layer. Okay, and one more thing he will do, session, or you can say dialogue management. Dialogue management. Dialogue management. It means allotting the sessions to different transmission modes. Allotting the session to different transmission modes. Sometimes say, what are the transmission modes, guys? Simplex, half duplex, full duplex. So somebody told full simplex, then I heard half duplex and full duplex, right? From one guy I heard simplex, right? Okay, whoever it is, let it be. So now simplex, half duplex, and full duplex. Okay, now so for simplex or for half duplex, you can assign minimum sessions. Okay, minimum time interval you can allot, because maybe at the other end somebody is gonna send. While for full duplex and all you can assign, or for simplex and all you can assign much more, say greater session. Clear? So assigning or say giving the sessions to different transmission mode, it is called dialogue management. Clear? Okay. So these are the upper layers, and I suppose you guys have understood it. Okay. Now shall we move on to the transport layer? Or before that, do you need a break? No or yes?
Yes.
Okay. I heard yes from somebody, so let me give some break. Okay. So what is the time? 6:24. Okay. We'll get back by, sorry, not 7, 6:30. 6:30. Okay. Yes. So guys, now the transport layer. Okay. So transport layer, let me tell you about the transport layer. The first thing, so here transport layer, you got two protocols. You got two protocols. Okay. First protocol is called TCP. And the second protocol is called UDP. Okay. So in transport, so first let me tell you about transport layer. Transport layer, it is say like it transports the inner protocols. Okay. Whatever say we have studied, say the application layer protocols and all, say the HTTP messages or the telnet messages or those messages, say that is transported using the transport layer, or the transport layer protocols will transport it. Okay. Now, so here you have two protocols, which is TCP and UDP. Okay. Now, TCP, it's called connection oriented protocol. It's called connection oriented protocol. And UDP is called connection less protocol. Let me tell you why. Connection oriented protocol means before sending the data, they have some mechanism. They have some mechanism. Okay, the usual example. I'll go with the usual examples. Okay, suppose Satish. Okay, so Satish is calling me. Satish is calling me. So once or when he calls me, say once I take the call, he's gonna say, suppose he has got some doubts to ask. So his main intention or his data, what he needs to deliver to me is the doubt. Okay, so after calling, or suppose when I have taken the call, he'll not directly ask me the doubt. Instead, he'll introduce himself, right? So he'll be telling, hello, sir, is it Bharat sir or not? I am Satish. Are you free or not? Then he'll tell me that, sir, I have some doubts. Shall I ask now? So there is actually a kind of connection establishment, a connection establishment. So he is making a connection with me. Once I got, okay, so once I got it's Satish, then I'll tell him, okay, Satish, I understood. Now I'm free. You can ask me the doubt. Then he will ask me the doubt. So then only the main things are delivered, or then only the data is delivered. Okay. Then once the data is delivered and suppose that I have cleared his doubts, then what he will do is that, okay, sir, my doubt is clarified or my doubt is clear now. So I'll now hang up the call, like that he'll say. So that is connection termination. Okay. So before, or say here in connection or in TCP. So before even sending the data, you got connection establishment procedure. Once the connection is established, then you will use the connection, or then only you will send the data. Then once you send the data, then after say everything is over, then you will terminate the connection. So this is what happens in TCP, and that is why it's called connection oriented protocol. Clear?
Yes.
Okay. Now about connection-less protocol, which is UDP. Connection-less protocol and UDP. So here in connection-less protocol, let me tell you. So in connection-less protocol, they're going to directly deliver it. They're going to directly deliver. There is no such mechanism called connection establishment or connection use or connection termination. They'll directly send the data. Clear? Example, Sadiq is calling his mom or dad or his girlfriend or his say friend or whoever it is. Say he'll not be telling, okay, this is Satish and all. He'll directly deliver, right? Suppose he's calling his mom or dad, then he'll be telling, it's not necessarily that, okay, is it mom? Is it, this is me? Are you free now? There is no such meaning in asking those things, right? They'll directly deliver it. Okay, the same thing happens. So if at all they got some messages, they'll directly deliver. Clear? So this is why it's called connection-less protocol. Okay. Now, one more thing. TCP provides reliable communication. TCP provides reliable communication. Okay. So that means, suppose I'm teaching you. So this is myself and these are you guys. Okay. So now, suppose I'm teaching you something. I'm teaching you something and you are nodding your head like this. Yes, you have understood. Right. So I can say this is a reliable communication. So whatever that I'm teaching you, I'm getting the reply that you have understood. Okay, so I'm getting the reply back, or I'm getting an acknowledgement back. So that is what the reliable communication means. You can rely. Okay, now suppose I'm teaching you and you guys are sitting like statue, like this, right? Okay, so if you are like that, okay, so I'm continuously delivering the, like, whatever I need to teach you, I'm continuously teaching, and everyone, maybe after some time you'll not even blink your eyes, you will sleep like this. So what happens is that, say, I can't understand whether you are getting it or not. So that's the non-reliable or unreliable communication. Clear? Okay, so that, say again, so the reliable communication means you're getting a reply back or you're getting an acknowledgement back. Say, suppose you are sending a registered letter, then you will receive the acknowledgement back, right? Say whether it is received at the other end, right? The same thing. So in UDP, it's like sending a postcard or just a simple post letter, whatever. Okay, you don't have any mechanism to check whether it has received or not. Clear? Okay. Now, so now I'll teach you about TCP. Okay, so before that, again, let me tell you. Okay, first, in TCP, I told you have connection establishment, connection use, and connection termination. Okay, so first let us go with connection establishment. Suppose you got a machine. This is the computer. Okay, and this computer is in India. Suppose it's in India, and it wants to send something to a computer which is in US. Okay, then again, this is the Indian computer and this is the US, or the computer in US. So once, or if at all, he wants to send something to the US machine, or if system 1 wants to send something to machine 2, he will send certain segment. He'll send certain segment. This segment, so this is the first segment which is being sent, and this is the connection establishment process. Connection establishment. So in connection establishment, let me tell you, they'll first send a segment, and this segment is set with a SYN bit. It is set with a SYN bit. Okay, 1 bit value is set, and that value is the SYN bit. So when the second machine receives this segment, he'll understand that the first machine wants to go for connection establishment. Clear? Okay. Now, if at all the second machine also is ready for connection establishment, he's going to send back an acknowledgement. He's going to send back an acknowledgement. It means whatever you have sent, I have received it. And I am also ready to establish the connection. So acknowledgement bit will be set and SYN bit will also be set. Clear? Okay. Now, so this computer will receive, the first computer will receive it and then will send an acknowledgement. He'll send an acknowledgement. So this is the connection establishment procedure. Okay. And this involves 3 messages, sending 3 messages. The first segment, receiving the second segment, and sending back the third segment. So this is called 3-way handshake process. 3-way handshake process. It's handshake. HANDSHAKE. 3-way handshake process. Clear? Okay. So after the 3-way handshake, there is a connection will be formed. A virtual connection will be formed. A virtual circuit will be formed between the first machine and the second machine. Clear? So this is the connection establishment. Okay. Now, after connection establishment, you can use the connection. You can use the connection, or you can start sending the data. Okay. Suppose you want to send a file. You want to send a file. This is the file. Suppose this is the file which contains, suppose, let me take smaller size. It consists of 4,000 bytes of data. It consists of 4,000 bytes of data. Okay, so even if it can go up to say many days, say suppose if you want to send a film, it would be around 1 GB or 2 GB file. Okay, so similarly, but I'm not going with the say greater values and all, I'm going with the smaller values now. Okay, so if you have a 1 GB file, actually you are not sending it in a single go. You're not sending the entire file in a single second. You're not going it like that. What you are doing is that you will split the data. You will split the data, or you will split it into multiple segments. It is split into multiple segments. So it is the size of the file is 4,000 bytes. Clear? Now, suppose it is split into 1,000 bytes here. Okay, and here also it's 1,000 bytes. Here also 1,000 bytes, and here also 1,000 bytes. It is split into 4 parts, which 1,000 bytes each. Okay, now suppose the first segment is having the data from the first byte to the 1,000th byte. It is having the data from the first byte to the 1,000th byte. And the second segment is having the information from 1,001 byte to 2,000th byte of information. Clear? Now, the third one is having from 2,001th byte to 3,000. Okay. And the fourth one is from 3,001th byte to 4,000th byte. Clear? Okay. So this is how they will segment it. Now, so you got source machine here and you got destination machine here. Okay. Now, shall we send the data now? Okay. Now, sending the data itself involves 2 methods. Sending the data itself involves 2 methods. First is called forward acknowledgement process. It's called forward acknowledgement process. And the second is called delayed acknowledgement process. Forward acknowledgement and delayed acknowledgement process. Forward acknowledgement means, say you are sending the data. You are sending the data. So you are sending the first segment. Then for the first segment, you will reply back an acknowledgement. Then you will send the second segment. You will receive back an acknowledgement. Then the third segment is sent. Then you will receive back an acknowledgement. So that means for all the segments sent, they need to send back an acknowledgement. Clear? Now, let me tell you here, this is the first segment. This is the first segment. But we can understand it. This is the first segment. But computer uses a number, or it uses certain sequence number. It uses certain sequence number to understand the segments. This is the first segment, right? This is the first segment. So the sequence number and its sequence number will be 1,000. Its sequence number will be 1,000. It means it consists of 1,000th byte of data. Okay, so the sequence number is 1,000. Now it receives back an acknowledgement. So the acknowledgement will have a number, and the acknowledgement number will be 1,001. It means it has received up to 1,000 bytes. It's expecting from 1,001 onwards. Clear? Okay. Now, again, the sequence. So then from 1,001 bytes to 2,000 he is expecting. So the second one will be sent, which is having the sequence number of 2,000. It consists of up to 2,000 byte of information. Clear? Okay. So here the sequence number is 2,000. Okay. Now, then the acknowledgement number here will be, what will be the acknowledgement number? Up 2,001. That means up to 2,000 he has received, expecting from 2,001 onwards. Clear? So this is the forward acknowledgement process. Okay. Now, again, we got one more method called delayed acknowledgement process. Okay. So in delayed acknowledgement process, let me tell you, they will send a group of segments. They will send a group of segments. Suppose sequence number 1,000 is sent, sequence number 2000 is sent, sequence number 3000 is sent. For everyone, for all the three segments or for the group of segments, they will receive back an acknowledgement. So the acknowledgement number would be 3001. It means up to 3000 bytes he has received. Now he's expecting from 3001 onwards. Clear? So this is the delayed acknowledgement. Got it? So this is how they'll send the data. Okay. Now, once the data is sent, then they'll proceed with connection termination. So let me tell you about connection termination. Okay. So connection termination, sorry. So this is the source. This is the destination, source and destination. Okay. Now, the source will send a segment. And this segment, so previously for connection establishment, the source send a segment set with SYN bit. This time, to notify the destination about the connection termination, he will set a bit called FIN bit. He'll set a bit called FIN bit. A FIN bit will be set. Now the destination will receive it and the destination will acknowledge it. He will acknowledge it and he will say he'll wait for some time to process it. And once he is processing the segment, then so this condition is called half close. This condition is called half close. It means the source, whatever source has to be done or the source needs to do, he has done it already. Okay, so that's the half close condition. So the source part is over. Now he'll wait for the destination to process it. And the destination, once he processes this segment, he will send back a segment set with FIN bit. Okay, so indicating that the destination machine is also ready to terminate the connection. Okay, now then the source machine will send an acknowledgement. Clear? So having say send the acknowledgement, then this condition is called full close. It's called full close. That means that I told you a virtual circuit will be created between the source and the destination. This virtual circuit will be terminated. Clear? This is the connection termination process. Any doubts? No? Okay. So this is the TCP. And again, say we have in the coming back to the delayed acknowledgement. Delayed acknowledgement itself are of two, say many types. Okay. So the first, let me tell you a processing called buffering. The process is called buffering. Buffering means you are continuously sending the data from source to destination. And that is called buffering. So there is a problem with buffering. Okay. Any guesses? What is the problem with buffering? Not collision. Okay. Here the collision does not come because it is in the transport line. Okay. So now
Segments may be delayed.
yeah, segments may be delayed. Yes, you can say. Okay. That is one thing. So that thing is called error. With delayed means suppose maybe after he'll wait for some time. Even after waiting for some time, he may not get it. So he'll assume that some error has happened and he'll assume that say some error has happened and then he'll take some measures. That is something else. We'll talk about it a little bit later. Okay. Now, let me ask you, what if I'm can't say any answer? Data loss also happen. That's also an error. Okay. So we'll talk about it later, a little bit later. Okay. Now, what if I continuously teach you for hours and hours and hours? Suppose you have joined a crash batch. Okay. Crash course or something. And suppose the counselor says the crash batch, you will be having 8 hours or 10 hours class per day or 12 hours class per day. Sorry. So what if I'm continuously teaching you for 12 hours? How will you feel? Tired, sleepy? Any more answers? Exactly the same thing only. No reaction. Exactly. Or you will become saturated. Maybe you will attend the class maybe maximum for a 1 hour or 2 hour, or say the usual, I suppose it's 45 minutes or something. I read it somewhere. Okay. You'll be able to concentrate only up to 45 minutes or something. I've read it like that. So suppose maybe after 45 minutes or 1 hour, your concentration, whatever you concentrate will be gone. And you will be like in some other movies or some other world or something like that, right? Okay. So now, so that means you have met the saturation point. Okay, the same thing happens here. Say if at all, where is it? Just give me a moment, guys. Okay. So if at all, the data is sent continuously. The data is sent continuously. Okay. So the destination machine, suppose he is unable to process this in that space. Okay, he's unable to process in that pace. Then what will happen is that this machine has got, say, a value or a temporary storage area called buffer. It's called buffer. So this buffer, whatever that you are sending, will be stored in the buffer, and it will get saturated or it will get full. So once it gets full, the problem is that, say, whatever that, again, after 1 hour, you will be in a different world. So after 1 hour, what I teach will be entirely, it is a waste. Right. The same thing, whatever, say once the buffer becomes full, whatever he is sending, it is a waste. He can't accommodate it because there is no space. So the destination machine will discard these things. Whatever is sent will be discarded. Clear? So this process, or when the buffer is full, buffer overflow will happen. Buffer overflow will happen. Okay. So if buffer overflow happens, then we have to, say, move from this buffering method. So again, the next method is called windowing. It's called windowing. Windowing method. Okay. Windowing means, say you got a source machine here and you got a destination machine here. Suppose I have sent two segments, sequence number 1000 and sequence number 2000. I've sent two segments. Suppose when I've sent two segments itself, this buffer has got full. So this computer will not only be communicating to the first computer, but will also communicating to other computers as well. So the buffer will have many values. Say suppose after sending two segments itself, the buffer got full. If the buffer gets full, then the destination machine will acknowledge. The destination machine will acknowledge. It's like, say you guys are telling me after 1 hour, you guys will be telling me, sir, we can stop for now. I have had enough. We'll continue maybe after 10 minutes or 5 minutes, right? The same thing. Okay. So he's gonna tell the same thing. Acknowledgement number, he'll acknowledge. So acknowledgement number 2000. Just give me a moment. So acknowledgement number 2001. It means I got up to 2000, expecting from 2001 onwards. Clear? Now, but my window is equal to 0. Means my free size. Say here, say I don't have any free size in my memory or in my buffer. So the window is equal to 0. Clear? So he'll update. So the source will then understand, okay, there is no free space in this buffer, so I'll have to wait for some time. Later, after having enough free space, then he'll respond back. He'll respond back something like this. Say, acknowledgement number 2001. I got up to 2000, expecting from 2001 onwards. Clear? And my window is equal to, suppose, say 1000 or suppose 3000. My window is 3000. That means I can accommodate 3 more segments. I can accommodate 3 more segments. So 3 more segments will be sent. It will be sequence number 3000, sequence number 4000, sequence number 5000, like that. Again, he will say send back the acknowledgement, or he'll update the window. He'll update the window. So this is the process of windowing, updating the window. Okay, so thereby avoiding the buffer overflow. Clear? You can note it down. Give me 2 minutes, guys. I'll just have water and cup. Okay. Yes. Okay. So I suppose you have completed writing it now. So this is the windowing processing. And now somebody has reminded of the error, right? Suppose, so you got the source and the destination. Okay. Yes, Ashwin? Yes. Any doubts? Sure. Okay. So now, so we have sequence number 1000. Okay. So now we have sent sequence number 2000 and we have sent sequence number 3000. Suppose due to some errors or data loss or something. Okay. So this one has not reached the destination. The second one has not reached the destination. If the second one has not reached the destination due to some errors or say data loss or whatever it is, okay, then they will perform, this is TCP, we are talking about TCP. So TCP has say error recovery procedure. Error recovery procedure. Error recovery means in case of any errors, what he needs to do. Okay, it's there in TCP. So what he will do is that, again, you got multiple methods and all. We'll discuss about one topic called adaptive retransmission. Adaptive retransmission. Adaptive retransmission. Let me tell you what it is. So if only the second segment is not received, what is the size of the second segment, guys? 1000 bytes, right? So this segment, the second segment, contains 1000 bytes of information. It means it consists of, say, 1001st byte of information to 2000 byte of information. 1001 byte of information to 2000 byte of information. So the destination will reply back like this. I got that, he'll acknowledge. So the acknowledgement number will be acknowledgement number 1001. Till or up to 1000, I have got it or I have received it. Waiting from 1001 onwards, 1001 onwards. And my window is equal to 1000. That means the size is 1000. It means, so the destination, so the source, when he receives this segment, he'll understand the destination is requesting for a single segment, which is sequence number 2000. Clear? And this segment will be sent, only this segment will be sent back. Say sequence number 2000 will be sent back. Clear? If everything is received, then he'll reply back like this. The acknowledgement number will be acknowledgement number 3001. Means up to 3000 he has received, expecting from 3001 onwards. And whatever is the window, he'll update the size there. Clear? So that is the adaptive retransmission method. He will ask the source machine to retransmit whatever he has not received. Clear? So this is the error recovery procedure. Okay. Yes. So this is the TCP, transmission control protocol. Okay. Now let me tell you where TCP and UDP are used. TCP is normally used in the, say, the usual internet, these packets and all. Say if you're watching a YouTube, or if you're watching some say suppose the browsing, internet browsing, those things are not. Okay, there TCP will be used. Now let me tell you about UDP. So UDP, say it is used for live streaming packets. It is used for live streaming packets. It means, say suppose you're watching a live in, say suppose India versus Sri Lanka, I suppose right now, right? So India versus Sri Lanka match or whatever it is that you are watching. Say suppose in Hotstar you are watching, say those are live video packets. Okay, so whatever that you are watching, it will be, say, sent by using UDP. Okay, and again, so if at all, again, you got some other protocols, suppose DHCP, say DNS, these protocols also use UDP. Clear? Okay. So TCP, again, you got many sub protocols, HTTP, FTP, these protocols. So Telnet. So these protocols use TCP for their transmission. Okay. Now UDP is utilized by, I told you, DHCP, DNS, and maybe like RTP, real-time protocol. Okay, which is used for the real-time voice packets, those things are now. Okay, so this is the use of TCP and UDP. Okay, now again, so coming back to the PowerPoint here. So first, transport layer. So transport layer, I told you, transport layer segments and reassembles the data into data stream. Okay, and that process of segmenting the data is called segmentation. Okay, now it provides end-to-end data transport services. End-to-end means from source to destination. Even if the source is sitting in India and the destination is sitting in US, it provides end-to-end service, transport service between the source and the destination. Okay, clear? Now, it is responsible for reliable delivery and it is performed using TCP, transmission control protocol. Responsible for creating and maintaining the logical connection between endpoints. We have discussed these things, right? Now, the two protocols in transport layer is TCP and UDP. Okay. Now, this we have discussed, and TCP and UDP. TCP, it has connection establishment, flow control, congestion control, acknowledgement, error recovery, reliable delivery. So these are the properties of TCP. And UDP doesn't have such properties. UDP doesn't have connection establishment, no flow control, no congestion control, no acknowledgement, no error recovery, nothing is there. And moreover, it's unreliable delivery. Clear? Okay. So TCP is used by applications, HTTP, FTP, SMTP, Telnet, etc. And DNS, DHCP, RTP voice. These are the protocols which uses UDP for transporting their details. Yeah. So this is the difference between TCP and UDP. Okay, and this and all we have already discussed, connection establishment process. So you can check it whenever I like share you the PPT. Okay. Now, so here UDP also I mentioned. So UDP doesn't have connection establishment. You already know it. I have already told you. Okay. And UDP, again, this also I told you for, it is used for multimedia application and say the gaming, those things and all, and the live voice packets or video. Say if at all you are using the WhatsApp and you doing the video call, those things and all, then say it is UDP. They are utilizing UDP packets. Clear?
How are these protocols are set, sir?
How are the protocols?
Are set. I mean, if it is how they are setting it is TCP, how they are.
It's already set in the program. So suppose in WhatsApp, if you use, say if at all it's a text message or something, it's already programmed in the, say, that software. So if at all it's a text message, you have to use this protocol. If at all it's the voice call or the video protocol or video, then you have to use this protocol. It's already mentioned there in the, say, that is the development side. Okay. So after developing, then now you have the WhatsApp in your hand. Now what we are studying is how this is working. Clear? Okay. So now, so I told you in transport layer, we have two protocols, TCP and UDP. So if say TCP is used, then I told you in transport layer, they will add a transport header. Transport header will be added. So the structure of the segment will be like this: the hi message, sorry, the application header, the presentation header, session header, transport header. So this transport header, if you are using TCP as the protocol, then you will have TCP header. You will have the TCP header. If UDP is used, you have a different header, which is UDP header. Both you will study. Okay. So now let me discuss about TCP header. We'll discuss about TCP header. So TCP header, these are the values. Okay, so in TCP header, the first value is called source port. You got some port values or port numbers. So before that, let me tell you what is this port number. Okay, so here, let me take the paint. Okay, suppose gone. Sajin, yes, Sajin is there. Sajin and Susmit. Okay, those are my usual, like, no, I don't want Susmit now. Okay, we got in like, what do you say? So my mother tongue, I told you, I'm from Kerala and my mother tongue is Malayalam. Okay, so we have a prominent, say, I suppose a famous dialogue in Malayalam. So it's like something like this. Ivaran in the Stiram Vetamega means like they are my usual, say, yes, whatever it is. Okay, so they are my usual, like, what is it, the word? Scapegoat or whatever. Okay, so now I don't want to like take Susmit. Okay, I'll go with Sajin and Ashwin now. Okay, so now, so yes, we got Sajin and Ashwin. Okay, suppose Sajin is talking to Ashwin. So he's asking a question. He's asking a question. So, what is your favorite bike? What is your favorite bike? Okay, now he's asking again the next question. Hey Ashwin, what is TCP? What is TCP. No such conversation will become, will be there between these two. But suppose he's asking a question like this. Okay. Then Ashwin, who's an intelligent guy, is able to understand. Okay. Just example, no hard feelings, please. Okay. So here, Ashwin, or he's a human and he'll understand, okay, this question is something related to bike. Okay. And this question is something related to the studying or technical related question. So he will understand that, right? Don't worry, I'll come to you. The next I'll take your example itself. I suppose Susmit is feeling like sad, right? Okay. So now, so he understood that it is, say this question is a casual question, or suppose like the bike related question, and this is the technical related question. But computer, it's actually, let me tell you, computer is a non-intelligent device. If at all something is programmed, he will be working like that. If it is not programmed, he doesn't have any logic, he will not work. So here, if you send, say, suppose one computer is sending one message to, say, first computer is sending something to the second computer. And again, another message is sent. So the computer needs to be told which type of message it is, which type of message it is, or which protocol it is. Okay. So here, suppose it is HTTP related message. It is HTTP related message. So here, when or while sending something to the second computer, the first computer will set a value. He'll set a value 80. Then the destination machine will understand, okay, as the value is 80, it ought to be, or it is an HTTP related message. Okay, the same thing. If he's sending some FTP related message, then it can be, number can be 20 or 21. Okay, suppose he's sending SMTP related message. Okay, then the number will be 25. The number will be 25. So when he has sent something, this number will also be sent. With this number, the destination machine will understand which protocol it is. And this number is called port number. It's called port number. Clear? So the port number, with the port number, you can identify which protocol it is. Clear? Okay. Now, again, let me tell you. So I was about to tell you one thing. I forgot. Okay. Let it be. So yes. So the port number, when you hear the port number, you may correlate it to as physical ports. You may correlate to as physical ports. But let me tell you, these port numbers are not physical ports. These are just logical ports. We cannot see it with our eyes. Okay. So if you ask me like, sir, show me the like port number 25, I can't show you because these are virtual ports. Only to understand, for understanding, we have set this value. Okay, so if at all you receive a message and if this message consists of a port number which is 80, then you will understand it belongs to HTTP, or the message is related to HTTP message or HTTP related data. Clear? That's the only significance. We cannot see it with our physical eyes or naked eyes. Clear? Okay, so this is the port number. So here, so I suppose now you have understood the port number, the source port number and the destination port number. Clear? So again, so if suppose one machine is sending something to the second machine. Okay, so the source IP will be, or say suppose if I'm sending something, say the same case, suppose Sajin is asking something to Ashwin. So the source, who is the source? Sajin is the source and Ashwin is the destination. So similarly, so there's the source name and there's the destination name. So similarly, you have source port number and destination port number. Okay, source port can be some random numbers for client machines and all. Okay, just understand these are some, say some numbers, that's it. Okay, so now, so these are the number, source port and the destination port. Clear? Now, you got something called sequence number. You got something called sequence number. Can you see at the back, guys?
Yes, sir.
Okay. Yes. So now this is the sequence number, and you know why or where sequence number is used, or why sequence number is used. Why it's used?
Segmentation to check the order and to process it again to the same.
Yes. Or To identify the
See.
sequence or to identify the segments. Okay, sequence number is used to identify the segments. So whenever you are sending the segments, you are sending the sequence number also. Okay, that means he can identify, okay, this is the segment and this consists of this must message so and so things are not clear to identify the segments. Now you got acknowledgement number. So that's if at all it's the acknowledgement which is being sent, it will be having the acknowledgement number, right? So if you are sending a sequence number, a segment 3000, sequence 3000, then it will receive back acknowledgement 3001. So that's the acknowledgement number. Okay. Now data offset. Data offset. So data offset means it defines the size of the TCP header. It defines the size of the TCP header. So the size of the TCP header can be from 20 to 24 bytes. The size can be from 20 to 24 bytes. Okay. So it just defines the size of the TCP header. That's it. Okay. Now you have something called a reserved bit or reserved field. It is reserved for future purpose. Reserved for future purpose. Something, suppose sometimes say later they have they'll come with some technology and they'll say or they'll use these reserved bits. Clear? Okay. Now you have some bit values. You have some bit values. So let me draw it here. I'm not sure whether you are able to see at the back. I suppose you can't see, right? This one. Okay. So now let me draw it for you. So here, okay. So the first is called CWR. It's called CWR, congestion window reduced. Congestion window reduced. CWR. And the second one is called EC or echo congestion. Echo congestion. Echo congestion. These both these bits are used for congestion management. These bits are used for congestion management. Okay. So I taught you that TCP, you will have congestion management. So these bits are responsible for managing the congestion. These things are not clear. Now, the third is called U, or it's called urgent bit. It's called urgent bit. Urgent bit means it represents if this value is set, then you have some urgent data to be sent. From the source to destination, you have some urgent data to be sent. The next is called A or acknowledgement. If the acknowledgement is sent, then this bit will be sent. Acknowledgement bit will be sent. Okay. Then the next is called push. P or push. Push the data. In case of insufficient data, suppose, just let me tell you, say some non-technical example. Okay. So suppose you want to travel from Bangalore to Chennai. You want to travel from Bangalore to Chennai. Suppose you are going in flight. Suppose you are going in flight. In flight, suppose you are going, suppose this flight can accommodate, say, suppose, or say 200 passengers. 200 passengers. And suppose, no, okay, you are one among them. Suppose, like, who is it? Again, Anish. Okay. So you don't look like that name. That's why. Means like we'll find some, like, if at all we see or we hear about Sachin, the name, then obviously we'll we'll have a picture of Sachin Tendulkar in our mind, right? Similarly, if you have friends like that, suppose if I have a friend Anish, then my mind will be going like his face. Say if at all we hear the name Anish, then we'll be thinking about that guy. So it's entirely different Anish here. Okay, that's right. So here, suppose, coming back. Okay, so guys, suppose sometime I'll be like going with these things and all. Okay, but we'll come back to the thing. Okay, so here, suppose we have 200 passengers and only Anish is, so one among is Anish. Okay, and only Anish came to travel, or Anish checked in. So 199% or the rest of the person, they didn't come. And what the airlines will tell, okay, we'll not take the flight because for a single person, we'll not take the flight. Okay, you can come in the next flight, right? But Anish, suppose he's an IAS officer. He's an IAS officer and he can push them, right? So in case of, even if only one person is there, you will have to take the flight for me, right? So that's what it is. So in case of insufficient data, that means since some packets, or it says suppose it's some data, you will not, or in some segments, you will not have enough data. You will not have enough data. So if it is not there, or enough data is not there, or if the size is low, then it will not be sent. They'll be waiting for some more data to come. Clear? So if push is set, if this push is set, then they will send the data. Clear? So that is push the data, or P. And the next is called R, or it's called reset. It's called reset. Okay. And then the next one, it's called, so let me delete whatever it's unnecessary here. Okay. So the next one is called S, or it's called SYN bit. It's called SYN bit. You already know about SYN, right? It is used for connection establishment. And the last one, it's the FIN bit. It's FIN bit, or it is used for connection termination. Clear? And these bit values are called TCP flag. These are called TCP flag. Clear? Okay. So this is the TCP flag. Okay. Now, so yes, so this is the TCP flag. Now you got something else called window size. It's called window size. So here they'll update the window. They'll update the window. Okay, so window means how much free space will be there. That's the window. And after that, the source will be sending some segments, and the number of segments that he sends is the window size. Clear? If 3 segments are sent, then that's the window size. Clear? Okay. So now, then you have a field called checksum. It's a simple error checking mechanism. Okay. Then you got something called urgent pointer. It's called urgent pointer. So while teaching you TCP flag, I told you got urgent bit. Urgent bit. If urgent bit is set, then that means you have something urgent to send. And then it points to the urgent pointer, which will tell you the data or the urgent data. Clear? So there's the urgent pointer. So these are the, and again, at last you got some options field. So some optional field is there. If it can be set or it will not be set, that depends. So this is the optional field, and this is the TCP header. Clear, guys? Okay. Now you will study one more thing called UDP header. Okay. UDP header, UDP is a light protocol. Okay, UDP doesn't have, say, the connection establishment, connection termination, congestion control, nothing is there. So UDP is a simple one, and so the UDP header is also a simple one. You can see it. Say this is the UDP header, which has a source port number. Okay, and this is the destination port number, and the length says what is the length of the UDP header. Okay, the header size, and at last you have checksum, which is the simple error checking mechanism. Clear? This is the UDP header. Clear? Any doubts? Okay. So, shall we wind up the class then for today? Because if I take the network layer again, it's gonna take some time. Okay. Yes. So today we'll wind up the class. So let me stop recording.